So we have a important question to consider, and that is how do we keep the electricity flowing if we go to a non-fossil fuel based kind of generation system? And there is a lot of interest in doing that. And so I thought I'd start out first by showing this image, sort of suggesting an integration of the two. Um, but that's really only a very, very tiny part of an answer. So let's go ahead and go to our outline on this. And that outline is found right here in this section, Electrifying the Grid, right there. And let's go then to the actual outline, okay? So I'm going to zoom in on this a little bit, just so that some of you who might be watching this on a cell phone can still see it, okay? I hope that's a little better for those of you in that situation. So, all right, so the electrification dilemma. And before I even go further, here's the thing with electrification, and I'll have a posting on this shortly. One way to decarbonize the grid, in other words, have less fossil fuel generated greenhouse gas emissions in the atmosphere to combat climate change. Okay. So one way to do that is to electrify much of the energy that we use. And one way we could do that is, for example, to run our transportation fleet more and more on electricity rather than, say, oil or diesel fuel, which comes from petroleum. Okay. So that's just a really quick look. But also, we don't necessarily need to burn natural gas in our homes either, do we? We could use electricity in an efficient way. So the electrification dilemma then, wind, water, and solar power, and I'm going to abbreviate those as WWS, can the intermittency challenge of renewables be overcome? So basically what we're saying is, could North America have a reliable electricity supply from wind, water, and solar without using fossil fuel generation? And just to kind of look at this a little bit, this is right now a glimpse of the electricity component that comes from the renewables. It's right here, the renewables being solar-based except for geothermal. So solar itself, hydro, and wind. And you can see that this is still a very small part of our total energy supply. If you just add up the fossil fuels, they are a very, very, very big part of our total energy supply in the United States. And in that, we have the electricity from the renewables, but also a lot of coal and natural gas is used to make electricity too. Okay, so going back then to the outline, how are wind, water, and solar distributed? Now, when I say wind, water, the water part is particular here. You might think I mean hydropower, and I do. But the thing about hydropower is we're probably not going to make much more in the way of generation capacity in the United States, and probably not in Canada either. So the existing system, I'm kind of leaving it as it is without really saying we can expand that much. So when I say water, I do mean hydro, but I also mean wave. And wave energy, though, is just in its infancy. It's one of the few technologies that we don't really have developed yet that would be very, very useful in solving this problem. And the reason we don't, by the way, lest I forget to return to this later, is because we're not serious about it. The amount of R&D spent on that is just a trickle. It's almost nothing, and yet it has huge potential. Okay, so let's look at the distribution of wind, first of all. This wind map is kind of a standard one from the National Renewable Energy Laboratory. It's actually on Wikipedia, but it's a very well-established government organization that does very high-quality work. And there's two things happening in this map. There's our transmission lines around, which is another topic, the grid, we'll get to a little later. And then there is the actual wind power for classification. So really good wind is anything from pink to purple to red and to blue, especially good. And you can see here in the Pacific Northwest that if you're just talking about on the land itself, and high resolution map would show this better. But we do have some decent wind resources up in here. So I'm going to get into the pinks and purples. Okay, but this is a fairly small area, and in fact, our wind productive potential in the inland areas in the Pacific Northwest is really very finite compared. Look at this. I mean, this is just amazing. Look at this map. Okay, so there's a huge potential in these states, the Great Plains, basically. Um, so then, of course, a lot of you are saying, "But wait, there's this huge offshore wind potential." Yes, there is, and there's a tiny bit of that happening here. But the North Sea in Europe is really where all that action is right now. And so it's just starting in the United States. We have really deep water offshore here, so we're probably going to eventually use, there's some permitting going on right now in Northern California on this, some floating platforms that were originally developed, interestingly, in the oil industry. And in Europe, the oil industry, state oil industries especially, but also the private ones, have been real active in developing offshore wind as another kind of source of power for the European continent. So that's a look at wind. Now let's go back to our sheet. So you can see that basically there's a very strong coastal pattern, offshore wind and coastal, the Great Lakes, and of course on the East Coast as well. Nice resources, but really the easy to develop wind is in the Great Plains, and a lot of has been developed there, much more than here in the Pacific Northwest. And then the next map I want to look at is solar. Let's see, get that to come up. And with solar, we can page down and look at a whole bunch of things here, but what I want to focus on is the annual map. And probably the best one here we can click on is this one. So the solar resource is huge. The really abundantly endowed regions are down here in the Southwest, but we do have some really good solar potential up in here too. Even if you take the very best solar areas here and the Willamette Valley is a little more than half. Okay, so that would mean it would be just a little over double the amount of cost to develop solar here as it is down here. But here's the amazing thing: some of the lowest cost solar in the world is being produced right here in the United States, a few cents a kilowatt hour, and we're going to get to that a little bit later. So that's a map. There's lots of solar, lots of studies on this. There's way more potential here than we could possibly use in the United States. Of course, we have the problem of night, and we'll get to that later. But even a small corner of the Nevada desert, if you just took the total potential kilowatt hours generated in a year, is enough to power the entire United States. Again, not practical for other reasons, but just to give you a sense of the magnitude of the resource. And these areas here are really well endowed, including into Texas. And there is a fairly vigorous Texas solar development in this region. Okay, so back to our outline. We now look at a wave map. And there are others, but wave is really an interesting one. Something to jot down in your notes about wave is, oh, by the way, the wind and solar were both plenty of either one of those could power on total terms the U.S. economy, but it doesn't address the intermittency problem. So we have enough, but we need to do some engineering to get that all to work well for us. We'll get to that in a bit. So the next one is the wave map, and you can see that the wave map energy is really pretty good here in our Pacific Northwest region and into northern and central California, as it is in much of the European continent and northern Africa and a lot of other parts of the world as well. Okay, and the advantage of wave, and here's what to write down for this class. For our own Pacific Northwest, wave is great because it peaks in the winter, and that's when our hydroelectricity from our dams is at its minimum for the most part, because most of it is British Columbia snowmelt. Okay, so snowmelt and the Rockies is a big part of that. Okay, now back to our outline. So we do have a lot of wave potential. We just haven't developed it, but it's out there. And maybe someday we will. I hope so. There's a lot of reasons why that would work very well. All right, so how would we do this? Okay, and right now we can just ask a bunch of questions, and one of them is by having a fully integrated continental scale grid with high geographic and source type diversity. Okay, now currently we don't have that. And I'll come to that in a moment. But let me explain what I mean by this. Okay, here's the simplest model. If I just said to you, hey, I got solar panels on my house and that's all I need for my electricity, you'd say, well, okay, what happens at night? Or what happens on a cloudy day? Or what happens when you're not there and you don't need the electricity, right? So that's why you have to have a geographic diversity. If we were trying to run our whole North American energy economy on solar, we'd want to be getting it from all over the whole region, including Mexico, including the western parts of the country, eastern, north, south, and so on. And even so, though, there's a time when all of that is at night. So we need not only source type diversity, i.e., not just solar, but we could blend that with, say, wind, and of course with our existing hydropower, and maybe someday with wave power. Okay, so the more diverse we are in our source types, the more stable the overall electricity supply would be for everywhere if we had a fully integrated grid. In other words, we could send electricity anywhere within the region. Currently, that's not the case. We basically have three grids. There's the Western, there's the Eastern, and then there's the Texas interconnect. And the problem with the Texas part of this, by the way, that we recently saw the multi-day blackouts, was because they decided they didn't want to integrate. And so they couldn't buy electricity from nearby states, which in many cases had enough. They could have easily supplied our Texas's shortages. But because Texas didn't want to be regulated by the federal government a while back, they said, oh, we're going to go on our own. And didn't work out very well for them for a whole bunch of reasons. But part of it, too, was because they just hadn't prepared for cold weather. So what I'm going to do now is try to hunt down how much time we've got left, because I think we're about done. So we'll pick this up in a bit in another video.